In this problem, we're integrating e to the 3x times sine of 1/5 x dx. This is the kind of problem that we'll have to use algebra techniques to solve it. Here, you would want to substitute your u with sine of 1/5 x. And your dv then is going to be e to the 3x. Derivative of u will be 1/5 cosine of 1/5 x. And then the integral of e to the 3x would be 1/3 e to the 3x. Now let's put it into the formula. So we will have uv, which is 1/3 e to the 3x times sine of 1/5 x minus v du, which is going to be 1/3 e to the 3x times 1/5 cosine of 1/5 x. Now here, we're going to use uv substitution again in this case, since we're still having a function that we're not able to integrate without using integration by parts. So in this case, we will have our u to be, let me write it here, we will have the u2 to be, again, 1/5 cosine of 1/5 x, and our du would be 1/5 squared, this will be negative, sine of 1/5 x. Our dv will be 1/3 e to the 3x, so our v would be 1/9 e to the 3x. Now again, we'll use the same equation, the same formula. We will have 1/3 e to the 3x times sine of 1/5 x minus, now it's better to keep everything in the parentheses here, since we're going to change signs later because of that minus sign we have right here. So let's do that. So now we have uv, which is going to be 1/5 cosine of 1/5 x times our v2, du2, dv2. v2 is going to be 1/9 e to the 3x minus, again, v du. So we have 1/9 e to the 3x times the du, which is going to be negative. Let's write the negative here, and we'll have 1/5 squared of sine of 1/5 x. There you go. Equals 2. Now let's open the parentheses here. Set the function that we're trying to find, which is this function. We could set this function to be equal to, let's say, y. So here, in this function, we could have, as we can see, we have the e to the 3x times sine of 1/5 x, which we could replace as y. So let's do that. Let's rewrite our equation. So we're going to have y to be equal to 1/3 e to the 3x sine of 1/5 x minus 1/5 cosine of 1/5 x times 1/9 e to the 3x minus, after which we come up with this equation. This is where we stop, because we could see that we're going to continue doing uv substitution, and we're still going to end up with something that we can't integrate. This is where we start using algebra. So we know that this is what we had to integrate. And then we have this to be equal to all of this. Now what we could do is, now notice here that our function y equals to the integral of e to the 3x times sine of 1/5 x. So that's where we're going to replace with the integral. So what we could do is we could pull out the constants, which is 1/9 times 1 over 5 squared, and then the integral of e to the 3x times sine over 1/5 x is going to be the y value. So from here, we could solve for y. So what we'll do is, we'll have this function to be transferred to the left side of the equation. We'll have plus 1/9 times 1 over 25 y equals to the rest of the equation, after which we get this expression. And from here we could solve for y. We could pull out the y, and we will get 1 plus 1 over 9 times 25 equal to the rest of this equation. And from here, to get y, we have to divide this whole function that we got by 1 plus 1 over 9 times 25. We could write it here. Divide each side by 1 over 9 times 25. I could erase this so that we avoid rewriting everything. That's it, plus c. Now, as we know, our y value equal to the integral of e to the 3x times sine of 1/5 x. Since this is the y value, then this is the integral. All of this is the integral of our equation. In this last problem, we're using integration by parts to integrate x to the 9 times cosine of x to the 5. Now, the way we would want to solve this is, if you think about it, if we have u to be x to the 9, and then we will get du to be 9x to the 8th. This is not going to be useful for us. There's nothing really we could do with this. It would be left out. So this would be not a good idea to have u to be equal to x to the 9. So let's try something else. How about if you do u equals to cosine of x to the 5? Now this is also not something you could derive. You would have to do u substitution for this, but we're trying to use u substitution for this whole thing. So this also doesn't work out. So what we could do is a little bit of manipulation. We know that we need to have u to be equal this value, x to the 5th. And once we do that, we will get du to be 5x to the 4th. Now what we have in front is x to the 9th, but we could pull out an x to the 4th from it. So what we'll get is x to the 5th times x to the 4th of cosine of x to the 5th dx. So once we have u to be x to the 5th, and we will get our du to be replaced by x to the 4th. But what do we do with x to the 5th? Well, here's the thing. We have our u to be equal to x to the 5th. So we can use this as well. Now we will perform our u du substitution. So we will get x to the 5th to be u. X to the 4th we'll have to derive from our du equation. So we'll divide both sides by 5, and we will get 1/5 du equals to x to the 4th. Therefore, x to the 4th is equal to 1/5 du. So we'll write the constant here, and du should go at the end. And now we will have cosine of x to the 5th, which is cosine of u. Now this looks like an integral where we have to use uv substitution. So we will have our, let's label it as U1. We'll have our U1 to be 1/5 U. du1 is going to be 1/5 du. Now we will have our dv to be equal to cosine of u. Therefore, the integral of this is going to be sine of u. Now we would use our uv substitution. So we'll have u1 times v, which is 1/5 u times sine of u, minus v times du1, which is going to be 1/5 sine u du. Now let's rewrite everything. We'll have 1/5 u sine of u minus the integral of sine of u is going to be negative cosine of u. So we'll get 1/5 times negative cosine of u. And the last step would be to replace the u with what we replaced it with, which was x to the 5th. So we will get 1/5 times x to the 5th sine of x to the 5th minus, now we have two minuses, so it's going to become a plus, 1/5 cosine of x to the 5th plus c. There you go. The rest will be simplified. I hope this video was helpful. See you in my next video.